Okay, so let's just jump right in. For years, the whole idea of connecting a human brain to a computer, that's been the stuff of science fiction, right? But what if I told you it's not fiction anymore? This technology is literally leaping off the page and into our reality, and it promises to rewrite the very code of our minds.
Just let that sink in for a second. This quote really sets the stage. It's pointing to a future where that line between our own biological thoughts and artificial intelligence just blurs. It becomes a kind of hybrid mind. And here's the thing. This isn't some far-off, someday kind of technology. We are already taking the first real steps into that future. It's happening right now.
So, what are we actually talking about here? Well, a brain computer interface, or BCI, is basically a bridge. It's a system that can read the electrical signals firing in your brain, your thoughts, really, and translate them into commands for something external, like a computer or robotic arm. Think of it like a direct line from your mind to a machine.
So let's start with probably the most immediate and honestly the most life-changing application of all of this, using BCIs to restore the body. You see, here's the problem a BCI can solve. When someone has a spinal cord injury, the brain's commands can't get to the limbs. The connection is broken. A BCI acts like a neurological detour. It creates this wireless bridge that just hops right over the damaged area, connecting the brain's intention to move directly to the muscles or maybe a prosthetic limb. Okay, so how does this magic actually work? Well, first, you have these tiny, super thin electrodes in the brain that detect the exact pattern of neurons that fire when you even think about moving your arm. Then, a really smart algorithm decodes that signal in real time. And finally, that digital command gets beamed over to a device, turning the pure thought of movement into actual physical motion. It's incredible. But, let's be realistic. This is still brain surgery, and that comes with some pretty serious risks. And the body is smart. It can build up scar tissue around these implants, which can mess with the signal over time. Plus, we're really in the early days of human trials, so we just don't know a lot about the long-term effects yet. All right, so we've talked about repairing the body. Now let's go a step further and tackle an even bigger challenge, repairing the mind itself. And this is where things get truly mind-bending. Researchers are actually developing what's called a hippocampal prosthesis. It's an implant designed to do the job of the brain's memory center. This could be a game changer for diseases like Alzheimer's that just devastate that part of the brain.
Now, building something like this is just unbelievably difficult. It can't just be a piece of silicon, it has to be biomimetic, meaning it has to act like real neurons, communicating in that same complex way. It needs to have a two-way conversation with the brain. And it has to be personalized for the unique neural code of every single person.
And yet, it's already showing results. Back in a 2018 human trial, patients using a model of this prosthesis showed up to a 37% improvement in memory function. A 37% boost. That is a stunning proof of concept. And it makes you wonder, if you can restore memory, what else can you do?
This brings us to the next step, the one that really pushes us into completely uncharted territory. We're moving beyond just repair and into the world of human enhancement.
You see, this is a huge philosophical shift. The goal isn't just to get people back to normal anymore. It's about using BCIs to actually extend our natural cognitive abilities, to potentially make us smarter, faster, and more capable than we are now.
So how would that work? Well, meet the neural coprocessor. Think of it as an AI partner living inside your brain. It learns to recognize when you want to do something, and then it stimulates another part of your brain to help you do it better and more efficiently. It's kind of like creating a high-speed shortcut for your thoughts, and it might even help your brain rewire itself for better performance over time.
So, where does this all lead? The possibilities are staggering. Early experiments, like one called BrainNet, have already shown people collaborating on a task using nothing but a brain-to-brain interface. We're talking about the potential for networked thought, a collective consciousness solving problems that are just too complex for any one person to handle. And that, of course, brings us to the massive ethical questions this all raises. When you can literally rewrite the mind, you have to stop and ask, what are the rules here?
For real, who owns your thoughts? If a company makes the device that's reading your neural data, does that company own your data? Do they have some kind of claim to your most private thoughts? This is the ultimate privacy question.
And then there's this. What happens to free will? If an algorithm outside your own mind can influence your mood or your decisions just by stimulating your brain, are you still really in control? Where do you end and the machine begin?
And what about society? If this kind of cognitive enhancement is super expensive and only available to the rich, could we accidentally create a neuro elite? A new biological class divide between the augmented and the unaugmented? That's a whole new kind of inequality.
So you can really see the two sides of the coin here. On one side, you have this incredible promise to heal devastating diseases and unlock brand new human potential. But on the other, you have the peril of medical risks, the very real potential for misuse and control, and the danger of creating a deeply, deeply unequal society.
So we're left with this question. This technology isn't just about circuits and code. It's about our identity, about our humanity, and about the kind of future we actually want to build. The ultimate question isn't just what we can do, it's what we should do.